Today we're going to look at a more in-depth view of energy. And as a reminder, energy is defined as the ability to do something or to do work. And we've talked about two overarching types of energy, which was potential energy, which is stored energy, and kinetic energy, which is moving energy. So potential and kinetic energy can be found in many different forms of energy. So there are different subcategories which contain both potential and or kinetic energy. So we have our two main types, potential and kinetic. And then there are other types of energy. There's electrical energy, which is the energy that's carried by electrons. And 8th graders, you'll remember that electrons are the negative charge in an atom. There's also light energy. So there's energy that comes from light, such as the sun, which if you have solar panels on your house or you know somebody that does, they're harnessing that solar energy, which is light energy, and that's radiant energy. There's also chemical energy, which is the energy that's stored within the bonds of atoms and molecules. 8th graders, again, that should sound familiar to you, because remember we talked about in molecules, right, ionic bonds, covalent bonds. There's energy that's stored in those bonds. When those molecules break apart, when the atoms break apart, that bond, remember, that energy is released. There's also mechanical energy, which is the energy of an object that has had work done to it. There's heat energy, so there's energy in heat. It's also known as thermal energy. So there's energy in heat from the heating system in the room or when you turn on the stove. And if you have a gas or electric stove, if you have a gas stove, it's easy to see because you see the flame come out and the heat. There's nuclear energy, and this is energy that's contained within the nucleus of the atom. So that central part of the atom where the protons and the neutrons are, there's energy in that nucleus. And the last one is sound energy. So the sound waves, they have energy in them. So that's another type of energy. So in electrical energy, we have kinetic energy. So there's things that are moving because the electrons are moving, so there's kinetic energy in there. Light energy also has kinetic energy in it because, again, it's moving. Chemical energy has both kinetic energy and potential energy in it. Right, so the kinetic energy is because the bonds there's energy moving in there, but then the potential energy is because when those bonds they're being stored, when the bonds are together, the energy is being stored in there. When the bonds break, so in a chemical reaction, that energy is released, which is kinetic energy. Mechanical energy also has kinetic and potential energy in it. So if you think about like a toy, like if you ever had like a wind-up toy, when you wind it up, there's that potential energy, it's being stored. But when you let it go and it moves, like my son has a car that when you pull it back, it's storing energy, so that's your potential energy. When you let the car go, it moves forward, there's your kinetic energy. Heat energy is kinetic. So there's moving energy in that heat energy. It's moving air molecules. It's heating up. Nuclear energy has kinetic energy in it and also potential energy in it. So there's moving energy in the nucleus, but it's also storing energy. There's also stored energy there. And the last one is sound energy, which has kinetic energy in it. So when you hear the car moving down the track, and you hear it hit the force plate, you hear the wheels turning, all of that is sound energy. That's kinetic energy being lost. Okay, and if you were to feel the wheels right at the end of the trial, you would feel some heat energy because there's heat being generated from the friction as the car's going down the track. So there's more kinetic energy that's being lost as the car's going down the track. So a way for you to more easily think about it is we use a simile, dogs are like energy. So if you think of it this way, there are two types of dogs, male and female. Just like there are two kinds of energy, there's potential energy and kinetic energy. So there's our dogs, our male dogs over here. Here's our extremely feminine female dog right here. Here's our potential energy and kinetic energy. So there are many forms or breeds of dogs, just like there are many or 7 forms of energy. So you have these two overarching categories, male and female. Within that category, okay, you have different breeds of dogs. And those breeds of dogs are either male or female. So we have our overarching types of energy, our potential energy, and our kinetic energy. Then we have these other forms of energy, these 7 forms that we just went over. And each one of those forms is either potential, kinetic, or both. So here are our dogs, more dogs. Some of them are male, some of them are female. Here's our energy. Our energy is either potential or kinetic or both. Another thing to understand is that this is very important, that energy can be converted from one form to another. So here we have our solar energy or our nuclear energy. It can be converted into heat and light. That goes to our plant, okay, which through photosynthesis turns it into chemical energy. It also lets off some heat. Now, the deer eats the plant, hopefully not a house plant, but a plant. And it turns that energy into heat energy, because it has body heat. Mechanical energy, right, because it has work done to it, it's moving. And also sound energy, because it does make a sound. And chemical energy, which is the waste. Now we have our hunter, right, who goes out hunting, he kills our deer. He now turns that energy again into heat, sound, and mechanical energy, right? He has body heat. He makes a sound, right? He talks, he walks, he makes sounds. He moves around, that's mechanical energy. So as you can see, what started out here as nuclear energy turned into several different types of energy. So it's not created or destroyed, it's just converted from one form to another. And this is why on your car crash rubric, right, you see a difference between the level of the amount of potential energy and kinetic energy, because it's still there, it's just lost in some different ways because we're not able to calculate how much energy is lost in sound, how much we lose from friction, how much we lose from any heat that's let go from where the wheels contact the track. So here are some examples of energy conversions. So if we look at a lamp, we have electrical energy from the outlet. That's our energy source. And it gets converted into light and also heat. So because, you know, if you ever get close to a light bulb that's been on, it's hot. Our cell phone, the battery starts out as chemical energy and it gets converted to electrical energy. We also see energy as light in the screen, sound from our ringtone, mechanical energy, right? Because if you're like me, it's always set to vibrate. So that's our mechanical energy, and heat energy. Because I think they've done a lot to help it, but your phone, especially where the battery is in your phone, can get very hot. There have been a few cases of iPhones setting on fire in people's pockets and things, and obviously they've done their best to make sure that that never happens, but there is heat energy there. If you look at our body, the human bodies, we get our energy source is chemical energy, which is we get from food, and we convert that into mechanical energy when every time we move around. Heat energy, we have body heat, we have a core temperature. Sound energy, we talk, we walk, we make sounds. And electrical energy, which is through our nervous system, so all those impulses and things that travel through our bodies, that from our brain to all the parts of our bodies that make our bodies work, that is electrical energy. So there are lots of examples here, and you can take a minute to look at the last few by yourself. All right, so please go to Edmodo. Make sure that you've taken visual notes on this video, and go to Edmodo to complete the Edmodo quiz.